Hello and welcome to the EPRI Current. I'm your host, Samantha Gilman, and today I'm joined by two EPRI experts to discuss the current hurricane season, what we expect, and how power companies can prepare for the extreme weather and harden their system to be more resilient to deliver reliable energy to their customers. So first off, Erik Smith, he is a climate scientist here at EPRI. And I'm also joined by Andrea Staid, a principal technical leader in our energy systems and climate analysis group. Thanks to both of you for joining. Now, you've both joined me on this podcast before, so we know who you are, we know what you do, but I'd still like to give you an opportunity to tell our listeners a little bit about the work you're currently doing and, how you ended up here, why this is how you choose to spend your time. So, Andrea, I'll start with you.
Yeah, thanks, Samantha. And thanks for the introduction. I'm really happy to be here. What we do, I spend nearly all of my working time thinking about climate resilience, thinking about how we can provide better information and better guidance for energy companies to understand the risks and plan for the risks, knowing that in some cases they are changing. And so why we're here talking about hurricanes, I think hurricanes they get a lot of attention for being extremely disruptive, right? And it's not just the power system that is disrupted by hurricanes, it's lives and livelihoods disrupted by strong winds, the rainfall and flooding that comes with hurricanes. And I've been thinking about and doing research on hurricane-related risks for a really long time, starting in grad school. And it's just been really great to continue some of that work here at EPRI through the Climate READi initiative, working with some great collaborators to really improve, our understanding of the climate piece, right? Like how might this change because of climate change?
And Erik, what about you?
Yeah, thanks, Samantha. Happy to be here. Erik Smith, I've been at EPRI for about 4.5 years. My background is meteorology. So I'm fascinated by weather. And at EPRI, I kind of look more at the long term. So the climate change aspect of weather. And I'm obsessed with data. So I try to understand the impact of climate data choice on power system modeling in different applications, because the data you choose has implications for how actionable your insights might be. So I spent a lot of time looking at data. I've worked with Andrea on this Climate READi initiative and done a lot of the foundational climate research and peer review publications focused on climate data choices and climate data gaps. And contributed to a lot of our public resources like the Climate Data Assessment and Inventory and our Climate Data User Guide.
Excellent. If I've learned one thing from Climate READi over the last 3 years, it is that data and the data you use is extremely important. So let's set the stage for our listeners. Erik, as I'm going to call you a weather nerd, I hope that's okay.
That's all right.
Hurricane season is here. What are we expecting this year?
Yeah, hurricane season kicked off June 1st. So hurricane season for the U.S. and Canada runs June 1st through November 30th, with the peak August, September, October timeframe. In Mexico, it actually kicks off a little earlier, around May 15th. And the reason being the Pacific Ocean gets going a little earlier, so you can often see hurricanes pop up at the end of May, early June, and off the west coast of Mexico. So NOAA puts out a hurricane seasonal outlook about 2 weeks before the season kicks off. So they put their hurricane outlook out at the end of May. And that is for the North Atlantic Basin, right? So the North Atlantic Basin encompasses the Caribbean, the Atlantic Ocean, so the Eastern U.S., as well as the Gulf. And for 2025, NOAA says there is a 60% chance of an above normal season. So for context, what is a normal season? 14 named storms. And by named storms, we mean anything from a tropical depression. So that's a storm that has winds of around 39 miles per hour or greater, all the way up to a Category 5 hurricane. So on average, we expect 14 of those, right? Across the entire Atlantic Basin. We expect 7 hurricanes on average, and 3 of those to be major hurricanes. For 2025, NOAA said there's a pretty good chance we're going to exceed that, right? So they're predicting somewhere on the order of 13 to 19 named storms, 6 to 10 of those to be hurricanes, and 3 to 5 of those to be major hurricanes. Now, it's not like all of those are going to hit the U.S., right? So roughly, a quarter of all named storms that form in the North Atlantic will make landfall in the U.S. And it's roughly a similar number for Mexico, but even less than that will actually impact Canada. But it only takes one. I think we saw that with Hurricane Helene, that it didn't even have to be a major hurricane. It just takes one storm to have major impacts.
That's right. Andrea, so we've been talking about Climate READi. What has Climate READi done in this space? And what can energy companies do to better prepare for this hurricane season, both in the short term, but also in the long term as the grid evolves and continues to focus on resilience?
Yeah, great question. So Climate READi has done some hurricane-specific work with some really great collaborators at Pacific Northwest National Laboratory, where we've been looking at using some of their research at projected changes in hurricanes themselves and bringing in some of our EPRI knowledge to couple that with power outage prediction models so that we can understand the changing risk from power outages because of hurricanes. More generally, Climate READi is providing guidance for utility companies on how to plan with climate risks in mind, how to better prepare for climate change. And so, with that hurricane-specific work from with PNNL, we look at the changing risks of power outages, and we have a lot of honestly really concerning statistics about what changing hurricanes might bring in terms of power outage risks. But then bringing it back to what Climate READi offers broadly, right? We offer guidance that covers all types of climate hazards, and we offer guidance for how to incorporate those hazards into the types of decisions that you're making around planning your system, investing in your system, upgrading your system. In the near term, those are largely going to be operational changes, right? You can't do much to physically change the grid right now, given that we're sitting here in the summer. But you can plan better for response and restoration. There are some operational measures you can take to sort of understand where that risk is going to be, make sure you have, crews in place and things like that. Understand the actual risk to customers and trying to minimize what the ultimate consequences might be from power outages. And so, the broad Climate READi guidance focuses on the long-term planning and also helps you understand the hazard risk itself and sort of characterize that in a way that can be used for operational decision-making.
Last fall, there were some conversations on this with our Vice President of Transmission and Distribution Infrastructure, Andrew Phillips. And on the short-term topic, he talked about some technologies that companies are using, such as drones or satellite imagery, to discover where those downed trees might be, where the crews need to go faster. Because in that short term, part of it is getting the crews to the locations where assets need to be repaired so that they can get the power back on. But as you mentioned, Climate READi has been more focused on the future planning and the adaptation strategies and investments and whatnot. I want to get back to what Erik was talking about earlier with the predictions for the hurricanes. Now, you said NOAA put out that there is a 60% chance that we're going to have a heavier than normal season. How accurate are those seasonal predictions? And how accurate are the hurricane forecasts between an active hurricane, tropical storm? How much can we plan on based on these predictions?
It's a really good question. And the good news is that there's no mystery with NOAA. So NOAA has all of their seasonal outlooks, all of their hurricane forecasts. They're cataloged, right? So anybody and everybody can go and see how they performed with their seasonal outlook or how their hurricane forecast performs, for any hurricane, going back, I believe, to like 1970, at least for the seasonal outlooks. So there's a lot of publicly available information that we can keep track of how skillful these predictions are. I think one thing to note, though, is that, NOAA will forecast the frequency of storms by category. So we talked about all storms, including tropical depressions, tropical storms, and hurricanes, as well as major hurricanes. So they'll forecast the frequency in the Atlantic Basin, but they're not going to forecast if a storm is going to make landfall or the frequency of landfalling hurricanes, and they're not going to try to forecast this far out where those landfalls might occur. If it's going to be Florida, the Carolinas. And the reason being, there's just not been shown to be much skill in that, especially 2 to 3 months out. And hurricane season officially kicked off June 1st, but the peak is really around August, September, October. So when you think about it, they are really forecasting for that 2, 3, 4 month ahead window, right? But all that being said, NOAA is very good at estimating the number of hurricanes for the season. If we look back 10 years to 2015, the total number of hurricanes that has occurred has fallen within their forecast range 8 out of the 10 years. So they're hitting it 80% of the time. And that's for all hurricanes. If you break it down just to major hurricanes, it's the same number. So they get it right about 80% of the time, at least for the past 10 years. Operational forecasts. So this is when you actually have a hurricane in the Atlantic Basin. And in the National Hurricane Center, which is an office of NOAA, they're the ones that take over and actually forecast the hurricane track and intensity. And that National Hurricane Center has been around for 70 or so years, and we have data on the track and intensity going back about 50 years. But the two primary skill metrics that they're looking at are, are they getting the location right, and are they getting the intensity right? And they do this for 5 days ahead. So they will provide a 24-hour all the way out to 120-hour forecast of intensity and location. And they catalog those. So we can go back and see how well they've done over the past 50 or so years. And, just looking at the past 5 years, because there's been tremendous gains or improvement in skill over the past 50 or so years. But over the past 5 years, the 24-hour forecast is usually within 30 miles of where the storm actually ends up. So within 30 miles of reality, and the intensity is within around 8 miles per hour of reality. So they're really close 24 hours out. But I think what's fascinating is that 5 days out, they're also like really, really good. So they're within 15 miles an hour of the intensity 5 days out, and within 100 miles of the ultimate location 5 days out. So to kind of wrap that thought up, 5 days out, if there's a forecast of a hurricane near your location, there's a pretty good bet that it's going to end up close by.
Another question I want to ask on that is, do we anticipate having those predictions this summer?
Yeah, the National Hurricane Center will absolutely be producing forecasts. There are aspects and I guess capabilities that might be hampered. So the National Hurricane Center will send flights into the hurricanes to gather data. So they will drop sensors into the eye of the hurricane. And that information is really critical. And the number of flights has already been said to be reduced this upcoming year. That will absolutely have an impact. I don't think it'll have, depend on how you define impact. It may not have a huge impact, but there's a couple examples that we could point to over the past couple of years where, a flight that was scheduled to take off did not, and we didn't get data over a critical 10 to 12 hour window. And the forecast was for a hurricane of a set intensity, but it actually rapidly intensified, was far stronger than what the forecast model said. And without that sensor information that the flight crews are able to gather, flying into the eye of the hurricane, you could have more of those instances where a storm could rapidly intensify beyond what you're modeling or predicting. And if that happens like near the coast, for instance, that's especially important because it doesn't give adequate time. And by adequate time, that I think we're usually talking 2 to 3 days to make plans and move people and evacuate and get crews established in the right location to fix lines or different assets. So yeah, great question.
Are there any other entities that would do that sort of data gathering, or is it really just NOAA at this point?
Yeah, I don't think anybody would really want to volunteer for that. I think there are certainly entities that can come in and help with forecasts, and maybe they've developed machine learning models. Private entities. Maybe they've developed models that have shown to be really skillful in ultimate hurricane track and intensity, or maybe high resolution precipitation models, but actually sending out a crew to measure information that has squarely fallen in line with kind of the role of NOAA to observe weather, to provide the fundamental information that those entities, those private companies then take and feed into their models. There's all kinds of implications and liabilities that come along with the role of NOAA. So it's pretty hard for the private sector to take over a lot of those different aspects.
So Andrea, given that uncertainty, related back to the previous question around preparedness, how can we think about energy companies making decisions given the uncertain nature of hurricane forecasts, both now and in the future?
There is some good news there in that most power system assets are designed to have a really long lifespan. And so if you are making an investment for what sort of infrastructure you want to put in a certain location, that's going to be there for decades, you hope. And while, there might be some uncertainty in this season's forecast or the forecast accuracy of an individual storm, there is a lot of really great research showing long-term trends, long-term averages of where we expect, or where we have seen and where we expect to see the greatest risks from hurricanes, both in terms of the winds and, the rainfall and the flooding. And that is the information that folks are making long-term investment decisions based on. And so there's a lot that we can still do. There's a lot that we know about, which parts of the country, which parts of the coast are expected to see high average risk from hurricane landfalls, both today and in the future, right? As we project this forward and looking at the impacts of climate change, we know a lot about what the conditions are likely to look like, based on, again, some uncertainty about emissions pathways. But if you sort of make some assumptions there, you can study those trends and you can make decisions about where wind speeds are expected to be really high, plan infrastructure accordingly to meet, wind thresholds, rainfall and flooding thresholds, et cetera.
So with the future outlooks and these trends that we see, how do different regions play into that? How does Florida react or plan for a hurricane versus how New York plans for a hurricane?
Great question. A strong hurricane is a strong hurricane, regardless of where it hits. The difference is largely that places that get hit more often are better prepared because they have been forced to repair, to replace damaged assets. The calculus is also a little bit different. If you have events that are much more frequent, then that cost-benefit trade-off is much more favorable in terms of putting the dollars, the investment dollars in place, because you'll see more benefits realized if more storms hit. So there certainly are differences in terms of how places like Florida are preparing for hurricanes compared to places like New York that have seen some really bad hurricanes, but they're much less frequent. But then there are also characteristics that just differ between the regions, right? The types of trees are different. The types of infrastructure in some cases are different, right? If you're thinking about Manhattan, where everything's underground, versus, suburban Florida, where you might still have a lot of overhead lines. But companies are taking localized risk into account, right? They're certainly taking hazard assessments that incorporate the reality of their locations and hurricane behavior in those locations. And so the decisions might be similar across, areas from Florida all the way up to New York. But that cost-benefit calculation might also be a little bit different and favor different solutions.
Erik, Andrea, I really appreciate you joining me today for a conversation around this hurricane preparedness and this current season. I know it's top of mind for a lot of those in the energy industry, and it's top of mind for even those not in the energy industry, as we are all consumers of energy and want to make sure that our own power stays on for our own needs. So I think this is a really important conversation, and I'm glad we're able to bring it to our listeners. But before we close out the episode, I want to give each of you an opportunity to leave any final thoughts and maybe something that you had wanted to mention that you didn't get a chance. So Erik, I'll start with you.
I think, a lot of people are going to be interested in understanding how hurricanes might change in the future. I guess I'll say that the jury's still out in terms of the frequency. So there's a lot of contradicting research in terms of frequency, but that's not to say climate change won't impact certain aspects or characteristics of hurricanes. We do know storm surge will be worse. We do know heavy precipitation in these events like Florence or Harvey or Helene could certainly be worse as we look forward in time in a warmer climate. So, I think it's important to take those into account and plan for those.
Andrea?
Building off of Erik's points, a lot of the work that we did with our colleagues at PNNL showed that, that there's confidence in an increase in rainfall, and that increase in rainfall also has a meaningful impact on the increase in power outage risk. And so power outages largely come from wind, but there's a large component that is also coming from heavy precipitation. And that's, I think, something to really be thoughtful of as we are planning for future risks.
Well, again, Erik and Andrea, thanks for joining me. And again, I'm your host, Samantha Gilman. Thank you to our listeners for joining us today, and we'll talk to you next time. If you liked today's show, we invite you to subscribe to our podcast and feel free to share with your colleagues and friends. For more information about EPRI, please visit our website at www.epri.com. And don't forget to follow us on LinkedIn and X at EPRI News. Together, we're shaping the future of energy.